Here is today's problem. We have a fraction with x minus 3 on top and a 3 on the bottom. That whole fraction sits inside parentheses, raised to the third power. The exponent applies to the entire fraction, not just the top. That is exactly what the parentheses are there to tell us. The full expression is set equal to the number 27. Our goal is to find every value of x that makes this true. Let us begin with the exponent sitting outside the parentheses. Cubing an expression means multiplying 3 copies of it together. So here we are multiplying 3 copies of the fraction x minus 3 over 3. When fractions are multiplied, the numerators all multiply together. The denominators multiply together in exactly the same way. As a small example, 1/2 cubed works out to 1/8. The top stays 1, while the bottom becomes 2 cubed, which is 8. So the numerator here becomes x minus 3 raised to the third power. The denominator becomes 3 times 3 times 3, the cube of 3. Now, 3 times 3 makes 9, and 9 times 3 brings us to 27. So the left side turns into x minus 3 cubed, all sitting over 27. Our equation now says x minus 3 cubed divided by 27 equals 27. To remove the fraction, we multiply both sides of the equation by 27. Multiplying both sides by the same number keeps everything balanced. On the left, the 27 in the denominator cancels away completely. What remains there is x minus 3, still raised to the third power. On the right, we need to work out the value of 27 times 27. We can split that product into 27 times 20 plus 27 times 7. Now, 27 times 20 is 540, and 27 times 7 comes out to 189. Adding the two pieces, 540 plus 189 gives us a total of 729. So the equation has become x minus 3 cubed equals 729. Next, we expand that left side into a plain polynomial. We write x minus 3 cubed as x minus 3 times x minus 3 times x minus 3. We start by multiplying the first two copies together. Every term in one factor multiplies every term in the other. First, x times x gives x squared, the leading piece here. Then x times negative 3 gives us a negative 3x. Next, negative 3 times x adds in another negative 3x. And negative 3 times negative 3 gives a positive 9. The two middle terms combine into a single negative 6x. So the first two copies multiply out to x squared minus 6 by plus 9. Now we multiply that result by the third copy of x minus 3. Once again, every term meets every term, one pair at a time. X squared times x gives x cubed, the highest power we get. X squared times negative 3 gives us negative 3x squared. Then negative 6x times x produces negative 6x squared. Negative 6x times negative 3 turns into a positive 18x. After that, 9 times x contributes a positive 9x to the pile. Lastly, 9 times negative 3 gives us a constant of negative 27. Now we gather up the like terms and combine each group. Negative 3x squared and negative 6x squared make negative 9x squared. Positive 18x and positive 9x combine into a positive 27x. The expansion is x cubed minus 9x squared plus 27 by minus 27. So the equation reads x cubed minus 9x squared plus 27x minus 27 equals 729. We would like one side of this equation to be 0. So we subtract 729 from both sides in a single step. On the left, only the constant term is affected by this. The constant becomes negative 27 minus 729 after the move. Since 27 plus 729 equals 756, that constant is negative 756. We now have x cubed minus 9x squared plus 27x minus 756 equals 0. The task is to find every x that makes this cubic 0. The leading coefficient of our cubic is a plain 1. In that case, any whole number root must divide the constant term. So every whole number root has to divide 756 with no remainder. Let us break 756 into prime factors to see those divisors. Dividing by 2 gives 378, and dividing by 2 again gives 189. Then 189 divided by 3 is 63, and 63 divided by 3 is 21. Finally, 21 divided by 3 leaves us with the prime number 7. So 756 is 2 times 2, times 3 times 3 times 3, times 7. The divisor list starts with 1, 2, 3, 4, 6, 7, 9, 12, and 14. One observation trims that list before any testing starts. If x were negative, the term x cubed would be negative. The term negative 9x squared can never be positive either. With x negative, 27x is negative, and so is negative 756. Adding for negative quantities can never produce 0. So no negative number can possibly solve this cubic. Only the positive divisors need to be tested at all. We begin at the bottom of the list and test x equals 1. That gives 1 minus 9 plus 27 minus 756 as the value. Now, 1 minus 9 is negative 8, and adding 27 gives 19. Then 19 minus 756 equals negative 737, far from 0. Next we substitute x equals 2 into the whole cubic. 2 cubed is 8, and 9 times 2 squared is 9 times 4, or 36. The linear part, 27 times 2, contributes exactly 54. So the total is 8 minus 36 plus 54 minus 756. That works out to 26 minus 756, which is negative 730. Still negative, so we move up to the divisor 3. Here 3 cubed is 27, and 9 times 9 gives us 81. The linear term is 27 times 3, which is also 81. So we get 27 minus 81 plus 81 minus 756 this time. The two 81 values cancel, leaving 27 minus 756. That equals negative 729, so 3 is not a root either. The divisor for comes next, so we substitute that in. Now for cubed is 64, and 9 times 16 gives us 144. The linear piece is 27 times 4, which equals 108. So the value is 64 minus 144 plus 108 minus 756. That simplifies to 28 minus 756, which is negative 728. 4 tests in, and the totals have barely moved at all. The divisor 6 is next in line, so we keep going. 6 cubed is 216, and 9 times 36 comes out to 324. The linear part is 27 times 6, which gives us 162. So we total 216 minus 324 plus 162 minus 756. That reduces to 54 minus 756, which is negative 702. After 6, the next divisor available to us is 7. 7 cubed is 343, and 9 times 49 comes out to 441. The linear piece here is 27 times 7, which equals 189. So we have 343 minus 441 plus 189 minus 756. That reduces to 91 minus 756, which is negative 665. The cube term is finally starting to pull ahead. The next divisor of 756 after 7 is 9, so we test 9. Here 9 cubed is 729, and 9 times 81 is also 729. Those two opening terms cancel each other out entirely. What remains is 27 times 9 minus 756 for the total. That is 243 minus 756, which equals negative 513. Much closer to 0, so we climb to the next divisor. On the divisor list, the entry right after 9 is 12. For x equals 12, the cube is 144 times 12, or 1728. The square term is 9 times 144, which equals 1296. The linear term is 27 times 12, which comes to 324. So we evaluate 1728 minus 1296 plus 324 minus 756. First, 1728 minus 1296 leaves exactly 432 behind. Adding 324 to that 432 raises the total to 756. Then 756 minus 756 collapses all the way down to 0. The cubic vanishes at x equals 12, so 12 is a root. Since 12 is a root, x minus 12 divides the cubic evenly. We divide to find the other factor of the polynomial. The cubic again is x cubed minus 9x squared plus 27x minus 756. Dividing x cubed by x, the quotient begins with x squared. Multiplying back, x squared times x minus 12 is x cubed minus 12x squared. Subtracting that leaves 3x squared plus 27 by minus 756. Dividing 3x squared by x, the next quotient term is 3x. Then 3x times x minus 12 equals 3x squared minus 36x. Subtracting again leaves us with just 63x minus 756. Dividing 63x by x, the final quotient term is 63. And 63 times x minus 12 is exactly 63x minus 756. That last subtraction leaves nothing, so the remainder is 0. A zero remainder is exactly what a true factor leaves behind. The quotient we have found is x squared plus 3x plus 63. So the cubic is x minus 12 times x squared plus 3x plus 63. We can expand that product and compare it with the cubic. X times x squared starts the expansion off with x cubed. X times 3x gives 3x squared, and x times 63 gives 63x. Negative 12 times x squared gives negative 12x squared. Negative 12 times 3x contributes a negative 36x. And negative 12 times 63 comes out to negative 756. Combining, 3x squared minus 12x squared is negative 9x squared. Also, 63x minus 36x combines into a positive 27x. That rebuilds x cubed minus 9x squared plus 27x minus 756. The factorization matches the original cubic exactly. A product is 0 only when one of its factors is 0. The first factor gives the equation x minus 12 equals 0. Adding 12 to both sides, that solution is x equals 12. The second factor needs x squared plus 3x plus 63 to be 0. For this quadratic, we compute b squared minus for ac first. That discriminant is 3 squared minus 4 times 1 times 63. It equals 9 minus 252, which comes out to negative 243. A negative discriminant means no real solutions from this factor, so the only real solution of the equation is x equals 12. To finish, we substitute x equals 12 into the original problem. We return to the very first line, before any expanding. Inside the parentheses, 12 minus 3 gives us 9 on top. Dividing that 9 by the 3 underneath leaves exactly 3. The outer exponent then tells us to cube this result. Now, 3 times 3 is 9, and 9 times 3 gives us 27, so the left side of the equation works out to 27 exactly. The right side of the original equation is 27 as well. Both sides agree, so the solution checks out perfectly. The answer to today's problem is x equals 12. That wraps up the solution for today's video. Thank you very much for watching all the way through. If the video was helpful, a like is always appreciated. Subscribing helps the channel share more solutions like this. We will see you in the next video with another problem.